During this quiz, you're going to use Microsoft Excel to do hypothesis testing on simple linear regression. Basically, that means you're going to see how to use Microsoft Excel to perform simple linear regression t-test. And also, we will construct confidence intervals for the slope parameter. For the materials discussed in this video also, you will need the data analysis tool pack. You have to first import the data analysis tool pack before using that, and it's not available by default, and you must have imported it already because for so many previous quizzes, we have already used the data analysis tool pack. Perhaps if you have to import the data analysis tool pack again, and in case if you cannot remember how to import the data analysis tool pack, there's a separate video explaining how to import the data analysis tool pack. And in this video, I'm not going to explain you how to import the data analysis tool pack, but I'm going to straight away use that. Okay, let's go to Microsoft Excel spreadsheet with the example. All right, so here's our example. This example was already discussed in class. We already know the answers for this question. The explanatory variable, the variable X for this example is the oil viscosity. And then the response variable, the variable Y for this example is the wear volume. Use the data given, X oil viscosity and Y wear volume, to test if the linear regression is significantly negative. For part A, we need to write down the null and the alternative hypothesis to be tested. So how do you write down the null and the alternative hypothesis? We know we define the slope parameter using the Greek letter beta. And the null hypothesis is therefore written as beta equals 0, and the alternative hypothesis is written as beta lesser than 0. Why is that? Because I need to test if the slope is significantly negative. So the answer for part A is null hypothesis beta equals 0 versus the alternative hypothesis beta lesser than 0. Part B, what's the appropriate statistical test procedure? It is simple linear regression t-test. It's okay to not include the term simple, but you have to write down at least linear regression t-test. Please do not write just t-test. T-test is something else. Here, we need linear regression t-test. That's the answer for part B. Part C, construct a 95% confidence interval and test the hypothesis. Interpret the test result clearly. Now, this specific test is a left-sided test. That means we will also need a 95% lower confidence interval. How do you start constructing a 95% lower confidence interval using the calculator? We go for a 90% two-sided confidence interval. And then we replace the lower limit with negative infinity. Using Microsoft Excel also, it is the same procedure. We are going to construct a 90% confidence interval as well. And then for that 90% confidence interval, we are going to replace the lower limit with negative infinity. Microsoft Excel will construct a 95% confidence interval by default. So whenever we define a different confidence level, such as 90%, Microsoft Excel will provide us two confidence intervals. One confidence interval is the default confidence interval, which is 95% confidence interval. The other one is the confidence interval for the level of confidence that we input. Okay, let's see how to perform the linear regression t-test using Microsoft Excel for this small data set. The size of the data set has no impact whatsoever on the procedure. And when I give you a large data set for the quiz, simply just follow the same steps that I explained in this video. To perform the simple linear regression t-test, I will go to Data, click on Data Analysis, and then scroll down, and you see Regression. Select the function regression, click on OK. Input Y range. I need to click on this little arrow. We have the option to select the variable label. So I'm going to go ahead and select the variable label. To select all the data points under that variable, what I have to do, I have to press Shift Control down arrow key. All three keys are pressed at once. All the data points for the variable Y are now selected. We can go back and hit Enter. Please remember, the first set of data entered is the variable Y. Okay? If you mistakenly enter X data points into Y and Y data points into X, the complete analysis will be incorrect. So please pay special attention to the definition of the variables. In the next field, I have to input X range. So I'm going to go ahead and click this little arrow. I have the option to select the variable label. So I'm going to go ahead and select the variable label for X, and then Shift Control down arrow key. Selected all the data points under variable X. I hit enter again. Since I included the labels, I'm going to check this box. Constant is 0. Just leave it blank. We don't need that one. Confidence level. You can see the gray default confidence level is 95%. But if I need a 90% two-sided confidence interval, what I have to do is I need to check this box, and I'm going to change this 95 to a 90%. Even though I changed that from 95% to 90%, MS Excel will also give me the 95% default confidence interval for the slope. Output range, I would like to have the output on this Excel spreadsheet itself. So I'm going to check this little circle, click on this little arrow, and simply select a cell outside of the data range. I will select an empty cell somewhere here. Click on this arrow again, or simply hit enter. In this case, I do not need residuals. I do not need any residual plots, or I don't need anything else for graphics. So this is basically all I need to input. So I'm going to go ahead and click on OK. So this is the output provided by Microsoft Excel regression test procedure. You can see there are 3 tables provided. To see all the stuff, you can double click at the end point of the column. The first table is for regression statistics. We have multiple R. Multiple R stands for the coefficient of correlation between X and Y. R squared, we already know what does R squared mean. And we have discussed those things during chapters 4 and 5. So I'm not going to revisit those things. Adjusted R squared is another quantity. It is considered slightly better representation than R squared. But we didn't discuss adjusted R squared in intro stats class. So I'm not going to address that one. And then we have standard error. I explained you how to calculate the standard error during the class discussion for hypothesis testing on simple linear regression. How do you calculate standard error? We need the residuals, and then we calculate the standard deviation for the residuals. That is called the standard error. Number of observations is 9. Of course, X had 9 data points. Y also had 9 data points, and they are corresponding data points. First observation of X must be read with the first observation of Y. The second observation of X must be read with the second observation of Y. So they are not separate. I don't have 18 data points. I had 9 in X, I had 9 in Y, and they must be read together. Therefore, I have total of 9 observations, pairs of observations. And then I have another table, ANOVA table. The ANOVA table also helps us hypothesis testing on the significance of the slope. However, we do not discuss ANOVA F-test for regression for intro statistics. We discuss ANOVA F-test only for multiple mean comparison as the last chapter of intro stats class. So for simple linear regression, we simply ignore the F-test. So simply ignore the second table provided. Instead, straight away go onto the third table. This third table is important. It gives us the equation in the first column, because x-intercept is 234.07. And then with x, the coefficient is negative 3.508. That means if I need to write down the equation, I can write this as y equals negative 3.5085x plus 234.07. And then we have standard error. Just ignore that second line. And then we have the p-values. The p-values are important. MS Excel compares the significance of slope, and it is always a two-sided test. So this p-value is not exactly the p-value we need. This p-value only indicates the alternative of beta not equal to 0, but we didn't test that. So we have to ignore the p-value. And the next 2 columns are important. They provide us 95% two-sided confidence intervals. Of course, I need to read along X. We don't want any confidence intervals for the y-intercept. Therefore, simply ignore the first row of this table. Instead, the second row of the body of the table has everything necessary with the slope parameter. Now, I'm not doing a two-sided alternative. Therefore, I do not need this confidence interval. Those two cells represent the lower limit of a 95% confidence interval and the upper limit of a 95% confidence interval. But what we need is a 90% two-sided confidence interval to begin the 95% lower confidence interval construction. So the 90% two-sided confidence interval for the slope is from negative 4.4389 to negative 2.5781. That means what should be your 95% lower confidence interval? The 95% lower confidence interval should be from negative infinity up to negative 2.5781. Now, based on that confidence interval, what can you say about our null hypothesis? The null hypothesis was read as beta equals 0. I need to see if 0 is found inside of that confidence interval. No, negative infinity up to negative 2.5781 is an entirely negative confidence interval. Therefore, 0 is not found inside of that. That means I can reject my null hypothesis. Rejecting null hypothesis means what should be the interpretation? Interpretation should be we have statistical evidence with 95% probability to conclude that the slope is significantly negative. That's the answer for that part. And then part D, test the hypothesis using the critical value method. Do you get the same answer? Can we test the hypothesis using the critical value method based on this table? Of course, we can do that. The second row of the last table is what we need, and it has the test statistic right here. So the test statistic is negative 7.14435. I need to see if this test statistic is going to land on the rejection region. Our alternative hypothesis is beta lesser than 0. That means it's a left tail test. So I need to know the critical value. But unfortunately, this output doesn't have the critical value. However, I have the number of observations from the first table. So the degrees of freedom for critical value should be equal to what? Is that 8 or 7? Well, only for simple linear regression, we said the t-test statistic has a degrees of freedom of n minus 2. So only for simple linear regression, when you have n equals 9, degrees of freedom becomes 9 minus 2 equals 7. So you can now use a TI-84 calculator, go to distributions, select inverse t, and then the area should be equal to 0.05 because that's the left tail area. Degrees of freedom should be equal to 7. And then select paste and hit enter again. You will see the critical value. And that critical value is a negative number. Therefore, the corresponding rejection region should be from negative infinity up to that negative value. And clearly, this test statistic of negative 7.14435 is in the rejection region. Therefore, also, we reject our null hypothesis. And we get the same conclusion as earlier. We have statistical evidence with 95% probability to conclude that the slope is significantly negative. That's the answer for part D. And then part E, what's the p-value for the test? Test the hypothesis using the p-value. Do you get the same answer? Well, unfortunately, we cannot use this p-value unless we are testing a two-sided alternative. So this p-value is for two-sided test. Therefore, we cannot go ahead and use that p-value. But on the other hand, we can use the given test statistic to calculate the p-value. So how do you calculate the p-value? This is a left-sided alternative. Therefore, the p-value should be area to the left from the test statistic. So we have to simply use the calculator. Use your calculator, go to distributions, and then select TCDF. And then the lower limit should be something negative and large. Upper limit should be negative 7.14435. Degrees of freedom should be equal to 7. Select paste and then hit enter. That should provide you the p-value for this test. Since the p-value is lesser than 0.05, which is our alpha, we reject our null hypothesis. So once again, we obtain the same conclusion. We have statistical evidence with 95% probability to conclude that the slope is significantly negative. Let's go to the next part. Part F. Test if the slope is significantly lesser than -3. That means I need to write down the null hypothesis, this time using -3. Null hypothesis is beta equals -3, and the alternative hypothesis is beta is lesser than -3. Now, how do I test that? I need a 95% lower confidence interval because this is still a left-sided test. I already have the 95% lower confidence interval. Here's the 90% two-sided confidence interval. So the lower limit is replaced with -∞, and the upper limit stays as -2.5781. Therefore, now I have to see if -3 is found inside of this confidence interval. Of course, it is inside of that confidence interval. Therefore, this time we accept the null hypothesis. That means, how would you interpret? We do not have statistical evidence with 95% probability to conclude that the slope is lesser than -3. Let's go to the next part. Test if the slope is significantly lesser than -1. This time, how do you write your null hypothesis? The null hypothesis is beta is equal to -1, and the alternative hypothesis is beta is lesser than -1. Once again, we need a 95% lower confidence interval, and we need to see if -1 is found inside of that confidence interval. So the 95% lower confidence interval is again from -∞ up to -2.5781. Of course, -1 is not inside of that confidence interval. Therefore, we reject the null hypothesis. That means we have statistical evidence with 95% probability to conclude that the slope is significantly lesser than -1. Part H, test if the slope is significantly greater than -1. This time, how do you write your null hypothesis? Null hypothesis is still beta is equal to -1. The alternative hypothesis is beta is greater than -1. It's a right-sided alternative. That means I need a 95% upper confidence interval, and I need to see if -1 is found inside of that. So we go back to the 90% two-sided confidence interval. It's right here. So what we need is a 95% upper confidence interval. So this time we replace the upper limit with +∞. The lower limit stays as it is. Therefore, our 95% upper confidence interval is from -4.4389 to +∞. And we need to see if -1 is found inside of that interval. Of course, yes, -1 is inside of this confidence interval. This means we accept the null hypothesis. Therefore, the interpretation is we do not have statistical evidence with 95% probability to conclude that the true slope is greater than -1. All right, so that's basically all you need to know about how to use Microsoft Excel for simple linear regression analysis. Thanks.